सही है ना। Assalamu alaikum. Okay, student. Today we discuss the topic that is the what is an inductor in a AC circuit. What is an inductor? An inductor is basically a coil of wire. It is a special property that is oppose any change in current passing through it. When current try to change through the coil, it create a back EMF opposite voltage. That is the property of the inductor, that is always oppose the current that is changing in the inductor. So here we write that what is an inductor? An inductor is a coil. An inductor is, sorry, writing. Inductor is a coil of wire. Okay, इसकी special property, it's a special property is that it oppose any change in current, any change in current passing through it. Inductor always changing the current when the current is passing through it. We already studied that the resistor property is that is always oppose the current that is flow through the resistor. Inductor property is that is always oppose any change in current passing through it. Okay. Whenever current want to increase or decrease, the inductor resist that change. Whenever current want to increase or decrease, the inductor resists that change. The inductor resists that change. Whenever the current in inductor want to increase, the inductor always resists that change, and whenever the decrease in the whenever current want to decrease, inductor always resist that change. Why? How the inductor resists that change? Inductor resists change by creating a back EMF. So here we write that an inductor does not like sudden change. Does not like sudden change. It means that if you suddenly want to increase the current or suddenly want to decrease the current, inductor does not like it. It want to slowly increase the current and slowly decrease the current. It does not like the sudden change in current. It slow down the change by creating a back EMF. Back EMF is basically that is produce the opposite voltage to the applied voltage to the circuit. It always create a back EMF when the current want to sudden increase or decrease. That is, we discussed that the what is an inductor. Okay, hope you understand it. What is an inductor and what is property? It always oppose any change in inductor. Okay, now we applied an alternating current or alternating voltage through an inductor. When alternating voltage to an inductor, so what happened to an alternating current? So now we discuss it. First we draw the diagram. uh, Sana, hi. Hi to Sana, welcome to my class. Thank you so much for watching my videos. Thank you all for who is watching my lecture. Okay, here we draw the circuit diagram of an inductor circuit when the alternating voltage is applied through an inductor. This is alternating voltage inductor, that is shows by here the capital L. This is the alternating voltage that is sinusoidally changed with time. Here it is the flow of the current in the inductor when the voltage is applied through the inductor. सना ने टेक्स्ट किया है जी, थैंक्स, वेलकम. No need to thanks. Thank you to you. You are watching my videos. Okay. Where I reach? Okay. Here we draw the circuit diagram. In the circuit diagram, we applied the alternating voltage to an inductor. So here we also write it. When we connect an inductor to an alternating voltage source, the current does not immediately rise or fall. The current does not immediately rise or fall. We discuss it last, that is whenever we want to increase the current in an inductor. Inductor does not want to increase the current immediately rise or fall because the inductor does not because the inductor oppose any change in current by producing a back EMF. What the property of inductor? It always create a back EMF when the current is rise or fall because an inductor oppose any change in current, any change in current. How it is opposed the current? By producing a back EMF, producing a back EMF. Okay, hope so you understand it. What happened to an current when it applied to an inductor? Okay, now we discuss the phase difference. What is the phase difference between the applied voltage and the current when it passing through an inductor? Okay, now come to the phase difference. Okay, always remember that an inductor current always lag behind the voltage by 90 degree in an inductor current always lags behind the voltage by 90 degree. Oh, zero student. Okay, now here we draw the diagram how the current lag behind the voltage. First we draw the graph of the voltage when they apply to an inductive circuit. Now we draw the diagram of the current that is lag behind the voltage by 90 degree. So this is the graph of the current. So here we write that this is the graph of the voltage and this is the graph of the current that is changing with time. So here we write that this means current takes time to build up in an inductor. So here we write that uh, voltage reach its peak earlier, but current reach its peak later. This is the property of the inductor, that is always oppose the change in current. When we apply the voltage across an inductor, the inductor does not want to increase the current suddenly, so current reach its peak later and voltage reach its peak earlier. So here the phase difference between voltage and current is the 90 degree whenever the alternating voltage source is applied to an inductor. Okay हो गया? Okay. Now move to the next topic. This is, we discussed that what is an inductor, what happened when the alternating voltage is applied to an inductor. Then we discuss the phase difference. Okay. Now we discuss the inductive reactance. What is an inductive reactance? The inductor offer opposition to the alternating current is called the inductive reactance. Always. Okay. Inductive reactance, when the inductor offer the opposition to the alternating current, is called the inductive reactance. So here we write that what is the inductive reactance? Okay, in resistor we discussed that the resistor offer the opposition to the flow of the current. Inductor offer the resistance to the change in the current. So here we write that the inductor offer opposition to alternating current is called inductive reactance. So here we write that the inductive reactance, that is always shows by X sub L. So X sub L, that is equal to omega L. Omega, that is shows the angular frequency. That formula is 2 pi f L. So this shows that the higher the frequency they move, the inductor resists the current more. The higher the frequency, higher the frequency of an alternating voltage source. So Inductor, it always the resists the current. The higher the frequency, the more inductor resist current. Okay, one thing remember that in DC current the frequency is not changed. So when the DC current is applied through the inductor, frequency is not changed. So inductive reactance is zero. But in this case, here we write that for direct current, frequency is zero because the alternating voltage source, they have the both half positive and negative, but in DC they flow in the one direction. So frequency is zero. When the frequency is zero, so inductive reactance is also become zero. That is why inductive inductor act like simple wire for DC. That's why that's why inductor act like simple wire for DC. Okay, हो गया. Now we discuss the power loss in an inductor. In a power loss in a pure inductor, average power is consumed, that is zero. Why the average power is consumed in the inductor case is zero. Now discuss it. Mhm. Average power. In the resistor case, we discussed that the power loss in the resistor case is always positive. So power consumed in the resistor circuit, but the in the pure inductor circuit, power consumed is zero. Why power is consumed is zero? Now we discuss it. Uh, say here we write that in a pure inductor, average power consumed is equal to zero. Uh, why average power consumed is zero? The average taken, sorry, the energy, मेरा भी दिमाग ना घूम गया. The energy taken from the supply during one half cycle is stored. When we apply the alternating voltage to an inductor, energy taken from the supply during one half cycle is stored in the inductor in the coil magnetic field. Whenever the current is passes through the coil, it creates a magnetic field. So the energy stored in the magnetic field and then is given back in the next half cycle. In the first half cycle, the energy is stored. In the next half cycle, the energy that is stored is given back to the source. So our one full cycle, so our one full cycle energy consumed is equal to 0. So there is no power loss in an inductor. So there is no power loss in an inductor. That is, we discuss the inductive reactance and power loss in an inductor. Okay, now last topic we discussed, that is the phasor diagram. Okay, now we discuss it, the phasor diagram, that is the last topic. Okay, in the phasor diagram, the phasor diagram of an inductive circuit, inductive circuit shows voltage arrow ahead by 90 degree and current arrow lagging behind by 90 degree. So here we draw the phasor diagram. This is the arrow of the voltage and this is the arrow of the current, because the current is always lagging behind the voltage by 90 degree and voltage is always ahead by the current. Okay, now we discuss the relation between voltage and current. Relation between, लाइट्स क्यों कम है, voltage and current. The equation of the alternating voltage is that is equal to V is equal to V naught sine of omega t, and equation of the alternating current is I is equal to I naught sine of omega t minus pi by 2. This equation shows that the current is lagging behind the voltage by 90 degree. This is, we discuss the phasor diagram. Hope so you are understand that about the inductor circuit and its property. Thank you so much for watching. Okay, in the next class we discuss that the AC through an capacitor. Today we discuss the AC through an inductor. That is all we discuss. Thank you so much for your watching.